Here we go, problem 10-9. Write a formula for the nth term of each of the following series. Letter A, 3 plus 10 plus 17 plus ... This series looks a lot like the sequence 3, 10, 17, ... This would be a sequence. This is the series. We're going to do the exact same thing to come up with the formula. So you've been doing arithmetic sequences and coming up with the explicit rule for a couple years now. The only difference here is now it just has plus signs written in here. We're still doing the exact same thing in terms of coming up with a formula for the nth term. So just think about the explicit rule for the sequence. So we're still going to deal with our terms and our term numbers. So we're still going to deal with our term number, and then this is our actual term. I'm going to just show it to you this way here because hopefully this will help you make the connection. I know that some of us are used to doing the zeroth term, so I'm going to put a 0 in there, even though right now we're not really dealing with the zeroth term, we're just dealing with the first term. But all right, we have a first term, a second term, a third term, and then it would continue on. We don't know the zeroth term, so I'm not even going to deal with it at the moment here. But our first term is 3. Our second term in this series is 10. Our third term is 17. As we're going through this here, we should notice that there's a common difference. That's how we know that it's arithmetic, because we're adding the same amount each time as we go from one term to the next. So in prior lessons there, or in prior courses, when you think about Algebra 1, you always had to go back and find what this zeroth term was. And we'll go ahead and do that here. If we were to go backwards, we would have to subtract 7, which 3 minus 7 would give us -4. So for those of us that are comfortable doing it that way, I'm going to show it to you this way, but you need to make sure you understand the new way of doing it too with the first term method. So I'm going to show you both ways here. So I'm going to put old method here. Okay, and this is when we dealt with the zeroth term, which is basically the same thing as slope-intercept form. Okay, and then we'll do the new one in a second. So our old one here, we'd be looking at t of n equals, and then remember we do the zeroth term, which in this case was -4, plus our common difference. Our common difference here as we continue on down the line here is +7. And then we'd multiply that times our term number. So t of n would equal -4 plus 7n. That is one way of doing it there. What we're trying to work on now is learning this new method, which is what we call the first term form. Let's call this first term. So what we're going to do with this one here is we're going to say t of n equals, now instead of going back and figuring out what the zeroth term is, we're going to use this first term. The first term in the series is 3. So we're going to list out 3. A lot of people like that better because it's like you don't have to go back and find the zeroth term. You just know that you're using the first term in the series. So we have 3 plus, and then we've got 7, which is still our common difference. And the difference now here with the last part here is instead of just multiplying it times n, we're going to multiply it times the quantity of n minus 1. So we could take a value and plug it in, and it should work in either one of these. If we put 1 into this one, the first term would equal -4 plus 7, which is 3. On this one, if we plugged in, what's the first term? We put in 1. We do 3 plus 7 times the quantity of 1 minus 1. Well, 1 minus 1 is 0, and 0 times 7 is 0, which still leaves us with 3 as well. So these will get us the same answers here, but we're going to be using this one a lot more as we progress through the chapter. So you want to make sure you're getting comfortable with that. And we'll explore the differences and the pluses and minuses of each of them here as we continue through the chapter. All right, let's look at the second one. If you maybe want to pause the video right now and try the second one and then see if you got it right, it would be a good idea. All right, so here we go. With this one, we're going to start out here just thinking about n and t of n. I'm going to do it the same way just to make sure that everybody's getting a grasp on the concept that we're doing here. So we don't know the 0th term, but we know the first, second, and third terms. And do you even have to list out this table when you're doing it? No, you don't. This is just to help build the connection with what you've previously learned in other classes. So 0th term, don't know. First term, 20. Second term, 11. Third term is 2. Now obviously, as we continue to progress through this series here, the numbers that we're adding are getting smaller and smaller, they're decreasing. So what are we adding to 20 to get 11? Well, we're adding a -9. To get from 11 to 2, we're also adding a -9. So that's our common difference. This is going to be -9. If we wanted to go backwards and find our 0th term here, okay, we would have to add 9. So 20 plus 9 would take us to 29 for that 0th term if that's the form we were using. So for our old form here, I'm going to kind of color code it here, the old method that we used to use, we would say t of n equals our 0th term, which was 29, minus, and our common difference is 9, right? So we're adding, you could say plus -9, or you could just do minus 9 times n. Or if we're looking at the new method here, we're going to say the new one would end up being t of n equals our first term, which is going to be 20, minus 9 times n minus 1. So you can go ahead and plug in values here to make sure that you get the same answers with either of them there, but all of these would work, but like I said, we're trying to focus on using this newer method, or the ones that I've written in red down here. So if you don't understand those, please make sure you're asking your teacher about it. Hopefully this one is coming back to you here if you haven't done it in a while. This is problem 10-9. Thanks for watching.